All right, here's an example of an exponential growth problem. The equation for the amount of oil produced is in the form. There you go. That's a leftover from the previous example on the page before. Here is the formula all written out for you. Y is the final amount. That's your answer. A is your initial amount. How much are you starting with? Whatever this problem happens to be, what's the starting amount? R is your rate. And remember that's your rate written as a decimal. T is your time. All right, so social networks, the number of users in millions that belong to a social networking site can be represented by y equals 1.5 times 1.40 raised to the t power, where t is the number of years after 2013. Interpret the parameters of the equation. Make a prediction about the future number of users. So that identify the parameters and you just break it down. What do we got? So the first number is 1.5. That's in the A spot. We are starting with 1.5 million users, initial users. The 1.40, what you need to remember is that is 1 plus R. 1 plus R gave us 1.40. Okay, so what is our rate? 0.40 is the rate as a decimal, so our rate is really 40%. It's tricky, because it's going to be tricky when we do decay, because that's going to be a subtraction. So that's right here. The rate of change R is 1.4 minus 1, or 0.4. Therefore, the number of users is growing at a rate of 40% per year. If this growth rate continues, then the number of users that belong to the networking site will rapidly increase, exceeding 40 million by 2023. How did they get that? 2013. We are looking for 2023. How many years is that? 10 years. So we would plug T as 10 into the formula, and that would be the answer. I'm not going to go ahead and do that for you. You can check it yourself. Stop the video and check it if you'd like. See if that really works out. So remember parameters. You are just figuring out what the things are you plugged in, and make a prediction. You're going to solve. All right, here's our next problem. Smartphone apps. The number of applications in thousands that are on the market for a smartphone can be represented by this function. And this t is supposed to be an exponent, so it should be 1.22 to the t power. It looks like that t is multiplying, but it's really a power, where t is the number of years after 2012. That's important. Interpret the parameters of the equation. Make a prediction about the future number of applications on the market. So first, let's figure out our parameters. So remember, y equals A. A was our what? Starting point. So we are starting with 320,000 applications in the year 2012. And then we want to figure out our rate. Our rate is somewhere in there. So let's write A equals, so we're clear. Our rate, 1 plus R, gave us that. So our rate was 0.22. 1 plus R, so 1 plus R is 1.22. That's 22%. It's going up by 22%. And make a prediction about the future number of applications on the market. I've got this plugged in Desmos already. So you can see the initial 0 is 320. 1, 2, 3, 4. So in 5 years, there's going to be 864,000 applications. So it's increasing, and it's increasing quite rapidly, wouldn't you say? What do you think? All right, so make a prediction. You can, I think for that answer, just give a couple. In 2 years, it'll be 476. In 5 years, 865. In 10 years, 2,337. Those would be great values to put in. So come over here. Remember, this is your type here box. So you can type the initial value is 320, which means we the number of applications is 320,000 in 2012. The rate is increasing by 22% per year. And in 5 years, and then you can say what it's going to be in 10 years, and so on and so on and so on. Those can be your predictions. So what do y'all think? Pretty easy? You're just substituting things in a formula. Actually, on these, the formula was already given for you. You're just interpreting it. Interpreting it. A, right here, the first number, starting point, whatever that is what you're starting with. This is 1 plus your rate. Your rate is written as a decimal. Got this? Yeah, I think you got it. Woohoo! Good job, guys.